Is my screen visible?
Yes, sir.
Are you seeing coordinate system in the screen?
Yes, sir.
Oh,
Yes,
oh,
sir.
oh, oh. Wait a minute, please. Okay. Once again, I am wishing you good morning and happy journey to this course or to this semester to everyone. I have been assigned to teach you electromagnetic field. Okay, this is the course name, and the code will be, I think, EN UG PC02. This is the code. So the code is not important. The subject course name is electromagnetic field. Um, so it's a 3 credit course. Two of the 3 credit course means 2 class will be taken by myself, and 1 class will be taken by Rimi madam. Mm, Okay, so it will be shared by 2 faculty members. This course will be shared by 2 faculty members. Let me introduce the subject well. First, let me introduce the subject first. Now, this uh, course has been segregated into several modules. Like in the first modules, you see it's called coordinate system. You will be given introduction to various coordinate systems. Okay, various coordinate systems. Now, in the second module, you will be given introduction to the vector calculus. Vector calculus. Perhaps this module you may already have gone through. Okay. Now, these 2 modules happens to be the foundation of this course. Okay. This coordinate systems, vector calculus, these 2 modules happens to be the foundation course or foundation modules of this course, because if you know these 2 modules very well, then you can solve the different problems of the subsequent modules. Okay, so learning of these 2 modules is very important. So next module it comes electrostatics. Now, what do you mean by electrostatics? Electrostatics. What do you mean by electrostatics? When charge remains, now in electrical engineering, everything starts from the flow of electron. Okay, the flow of electron. Now, in short, we call electron as charge. Okay, you know, proton and neutron stays inside the nucleus of an atom, so they cannot move. They are not allowed to move. Only particle moves electron. So moving a charge or moving a particle means it's an electron. So whenever a charge, or most technically, more technically, if you say, if a electron is at static position, is at rest, then whatever uh, phenomena or whatever activity is observed is dealt in this electrostatic module. This is electrostatic. So the name itself, you will see this one term is called static. So from there, electrostatic names comes. So now next part, the next module is magnetostatics. Magnetostatics. What is this magnetostatics? Now, when you say when you say your charge is at static position, then immediate the counter of that will immediately come. That charge must be moving. When you say charge is a static position, then one time will come or some point of another, the charge will move. Charge will rotate or not rotate. Charge will be not in static position. It will be moving. Now, when the charge is moving, obviously with respect to time, we measure it with respect to time. The question comes whether it is moving in a uniform rate or non-uniform rate. See, charge, if the flow of electron is uniform with respect to time, then we say this one has a DC current. This one has a DC current. So whenever charge is moving in a uniform rate, then that activity, whatever activity is happening, so that will be dealt in magnetostatics. And whenever charge is moving at non-uniform rate, that part will be dealt with electromagnetics. Okay, electromagnetics. So again, I am telling you, these two, the highlighted by red, these two are the foundation modules of this course. If you do not know them, if you do not learn them well, you could not able to learn the rest. So if you learn them well, then you can able to understand the concept of these three. Okay. So whatever activities is happening, all will be explained in these three modules. Perhaps all the activities like how current is flowing, how voltage is generating, how flux is creating. Okay, all these activities, necessary activities, all will be explained by these three modules. Okay, that is Lenge's law, electromagnetic laws of Faraday's law of electromagnetic induction. All these will be covered in these modules. Okay, these three modules. And another, apart from these three modules, you will see uh, when you say the voltage and current, so it must have some source, it must have some destination, so it must have some propagating medium. So final two modules will be, six will be electromagnetic wave propagation, electromagnetic wave propagation, and finally the last module will be, last module for this course will be transmission line. Last module for the course will be transmission line. So this course will be uh, will consist of this following this seven modules. Okay, so five first five modules is important. Okay, uh, then if time permits, then because in this semester time is less, and apart from the time we have so much holidays coming, it's puja holidays, then Diwali. Okay, so time is limited in this semester, so if time permits, these five modules will be covered surely, but after that if time permits, then these two will be uh, covered, these two will be discussed. Okay, so this is all about the structure of this course. Now let me tell you, course is this course is highly conceptual and it's mathematical. Uh, this course is highly conceptual and mathematical, so you need to pay attention. Now, in this online system, it is not possible for me to control your presence. To control your presence, that means if your icon is really showing on my PC, that does not guarantee that you are present on the class. It may so happen that your icon is there but you are not there in the class. You just show your face at the beginning and you come after 1 hour time and you give your attendance, okay, at the end of the class. So I am not saying that you do it, but it is a possibility. Okay, you can do it, and people, um, normally we have seen such things. Okay, normally when at the end of the class we call by the name of the students or by the roll number of the student, they simply don't respond. That means what? They are not present at that time. So this is happens in reality. This happens in reality. So what happens is that it's not for me, for any person, any faculty member, it's not possible for him or her to control your presence, whether you are really present or not. So that is why I am not here to take your attendance. Okay, my first and foremost job is to make you learn this subject, not to take your attendance. You please keep this in mind. Okay, I am here to make you learn this subject so that uh, you can apply this subject knowledge to solve some real problems, or or these knowledges can help you to uh, apply in somewhere else. So my main objective is that to make you learn. I am not here to take your attendance. So from next class onward, I will not take any of your attendance. Okay. So if you want to learn the subject, if you want to really want to gather some knowledge, you please pay attention and please be attentive to the every class. Otherwise, if you have if you find, if you do not find any interested, no problem, you please don't attend any class. I will simply don't matter. I'll not, may not matter at all, because attendance is not important for me. Okay, so this is my first thing I say. And secondly, again I am telling you, my first job is to, first and foremost objective is to make you learn. So if you really want to learn something, learn from this subject something, so you please try to listen first, try to understand something. If you have any problem, you please share. At any time you stop hearing, you stop me and you please ask me. Okay, whether at any time if you find any difficulty, if you then you can stop me and you can ask me, and you please clarify your doubts. Okay, now at the end of the each class you will be given a recording, the link. uh, you will be given a link, everybody. I have made a group mail of yours, so you can access that mail, you can access to that link, and you can access to the video of each lecture. So that is there with you. At the each of at the end of the each class I will be giving the video link of each lecture. So you will be having that, no issue with that. And and most importantly, for CR I am telling, if any classmate of yours misses the link, uh, I have made the group email ID with the available data with me. So if anyone does not receive any emails from my end, that means your mail ID is not included in your group. Such person or such fellow should immediately contact me, and I should incorporate him. I should incorporate his or her email ID to that group, so that everybody, whatever is happening to the class, everybody gets information and everybody gets update. Everybody will be updated. Okay. So with this, is there any doubt? Is there any
No,
doubt,
sir, not at all.
anybody?
No, sir. No, sir.
Okay. And one more important information I must tell you right now. The books you will follow Sadiku. There is a book author named Sadiku. You can follow his book. This book, very good book. Okay, right? Sadiku. This author name is Sadiku.
So what is the name of the book?
Name of the book I do not know exactly right now. It is available in our library. I don't know whether you will be given access to the library in this time. I don't know. So if you really want to access it, you can buy it. Okay. Or at least you can wait for some time. Okay. At least 1 month time. I don't know whether you will be given access to the library or not. Okay. So that part I cannot help you. I will supply your materials made by myself, that is PDF. uh, if you find help from there, then it's well and good. Okay. So
Okay, sir.
is there any question?
So do you have any PDF file to Sadiq?
I have shared two PDF files I have shared.
Okay, sir. I will collect.
No, didn't you get the email from mine?
No, sir. I don't have. Sir, no, sir. No email.
So I have sent two PDF. So please, anybody from the class, did you not receive that? Didn't you receive that? Anybody? Two
Sir,
PDFs I have shared. Okay, that is okay. But if the first list is there, it does not mean that all students will be excluded or all students take took admission in other institute. There must be at least some 10 or 20 students will be there
হ্যাঁ স্যার
in
এসছে
that list.
আমার আমার এসছে
Okay. So
স্যার
in that
বলছিলাম
case, yes, bolo.
বলছিলাম যদি আপনি একটা ক্লাসরুম বানিয়ে দিতেন এই পার্টিকুলার
No,
সাবজেক্টের জন্য
I don't create classroom. I don't create. I will teach. I will give lecture in this way. The Google link or the Google Classroom meeting link will be same. Okay.
হ্যাঁ স্যার
What?
মিটিং লিংকে তো পড়াবেন কিন্তু বলছিলাম স্যার ক্লাসরুমের সমস্ত ম্যাটেরিয়াল গুলো এক জায়গাতে কালেক্টিভলি থাকতো
So you download You download and you store in your PC. You download your material and you store in your PC. In the Google Classroom also, if I give you the materials in the email, so those materials, the e-version of the materials will remain in your email ID. So the basic purpose of Google Classroom, I am telling you, is to provide you the video link. Okay, the first and foremost purpose is to provide you the video link, video lecture. So I will give you, no issue with that. Video link I will share with you. And most importantly, I request here to please share me the updated student list so that every legitimate student, every present student can access all informations what is happening in the class. I request here to please share the updated student list. Okay. And whatever PDF, whatever material I will be sharing, you must download it and you must keep it in your desktop or PC or mobile, whatever it may be. Okay. I don't use lecture in this way. But however, my Google Classroom or not Google Classroom, my this Google Meeting link will be same for the entire semester. Okay. So is there any question? Anybody?
No, sir.
So I please, so Seer, whoever he is, please, who is Seer? Please show your face. Please show your face. It's not visible actually. So okay, it's not coming due to maybe some network problem. So you please share the updated list of the students. Okay, within today or maybe tomorrow. Okay, so I can give you the. Okay. So I'll take care of that. And also, and you please, uh, from the previous list, who is not belonging to Alia University now, you please make that mention. You make mention of that, okay? So that I can delete those IDs. Okay. So you have the old list, you have the updated list. So you please mention the old list. Who are the students who are not presently, not the students of Alia University presently. Okay, so I can delete the IDs from the group mails. Okay, thank you. So let me start with this lecture. The first topic will be coordinate system. Wait a minute. My computer is very slow actually. That is why some. So our let us start with our first topic, that is coordinate system. Coordinate system. We have first coordinate system, simplest of all. It's called Cartesian system. Okay, you all know this. You all heard this name, Cartesian system. Okay, have you heard Cartesian system? Anybody? How do you define Cartesian system? You please, when I ask this type of question, you please respond. Okay. Is the screen is visible?
Yes, sir.
Oh. So this is a three-dimensional space. Let us represent in this way. Everybody do it like that. So this is x-axis, this is y-axis, this is z-axis. Simple. It is simplest representation of all. So any point P in a three-dimensional space can be represented by a point x, y, z. Any point P can be represented by a coordinate x, y, z. Okay. What is x? What is y? What is z? You know, x is the distance from origin along x direction. Along x direction, x is the distance along x direction. Then what is y? Y is the distance along y direction, and z is the distance along z direction from the origin. So this is the definitions of Cartesian system x, y, z. Okay. Our second system is called cylindrical system. Our second system is cylindrical system. What are the parameters and what is the definitions of them? Have you heard cylindrical systems? Anybody? Anybody? No one? Hello, am I audible?
Yes, sir, you are audible, but we haven't about cylindrical system.
Okay, okay. So I told you now. You please respond whether you yes or no. So say same three axis x y z. Now same point, P, same point P. Now in this time instead of using x y z, we use some different variables. R, there are phi z. There are phi z. What is r phi z? What is r phi z? It is r. Then second variable is phi, and it is third variable is z. Now let us define. Let us define what is r, phi, and z. So this yellow shaded this portion is called xy plane. This is xy plane. So if you simply thinking of your room, so it is a perfect example of a three-dimensional space. Whether in where you will find the your floor in a three-dimensional room or any room, you will find your floor and your roof. Your floor and your roof are xy planes. That means xy planes, when I say xy planes, I mean in this variable or in this plane, x and y, these two variables, these two parameters are varied, and third variable z remains constant. Similarly, two opposite walls are one pair of walls is xz plane and other pair of walls is yz plane. So you see, if you take any one pair, let us consider floor and roof. You will see that in there z is constant. Z means the vertical height remains constant. So if you consider your floor, then z must be equals to 1. Z must be equals to 1 or z must be equal to 0. That is, it is placed at origin. And when you consider the roof, so the z should be 10 meter or maybe 15 meter, whatever is the vertical height of the room. So whatever in case it may be for floor or maybe roof, for both of them z is constant. Only x and y, these two variables, these two parameters are variable. Okay. Similarly, this is xy plane. Okay, so this is, you can consider this one as floor. Okay, so you straight away directly take a mirror image. You directly take a image, photographic image of that p point. That is your point. Okay, so you directly take the image. You take a image of that p. So let that point be p dash. Let that point be p dash. Let that point be p dash. So what is p dash? P dash is nothing but the image of. So if you observing from here, it is your eye. It is your eye. So if you looking from this view, if you looking from this view, so it is p dash is nothing but image of p. Okay. So what is p dash? So what is p dash? So if
Nothing but
my
the image of P.
sorry, I didn't hear you.
P dash is nothing but the image of P.
Exactly. So let us say this is the p point, this finger, okay, and my palm is the xy plane. So if you take directly the projection or the image projection, maybe then that projected point is nothing but P dash. Simple. So once you have the projected point, you directly join that projected point with the origin. You directly join the projected point with that origin. So this line is your R. This line is your R. This line is your R. Okay. This is the definition of R. So it is the line joining between origin and the projected point of the original point on xy plane. So this is the R. What is phi? Phi is the angle between this R and positive x-axis. Angle between this positive x-axis and R. This is phi. And the definition of Z remains same. It is the vertical height. Is the vertical height as it is same in case of Cartesian system. As it is same in case of Cartesian system. So you understood the definition of what is R, what is phi, and what is Z. Z, it is nothing new. Z is already known to you. Now, you know, you understand what is R and what is phi. Anybody, any doubt? Any? Okay. So if you erase or if you erase this Z for the time being, let us consider P is defined by R phi Z. Okay, this is the definition. This is the definition of cylindrical system. Now let us, for the time being, you think Z is not there. It is only R and phi. So perhaps you recognize this as you have done, you might have done some conversion from Cartesian to polar coordinates, or vice versa, from polar coordinates to Cartesian coordinate. You did it. Yes or no? Have you heard the polar coordinate or polar form? Have you heard? So if it is okay, so if it is no, then I'll left with this. I will not discuss. So this is all about cylindrical system. So third system is the spherical system. Our third system is spherical system. Spherical. Okay. So any point P, same diagram. This is x axis, this is y axis, this is z axis. So any point P. Now in this way, in this spherical system, it is defined by r theta phi. R theta phi. So this is the definition of spherical system, r theta phi. In case of Cartesian system, it is xyz. In case of cylindrical system, it is r phi z. And in case of spherical system, it is r theta phi. So what is the definition of r theta phi? It is r is now, in this case, r is defined by, it is the directly line joining from origin to that point. It is r. Previously it was line joining from origin to the projected point. Now it is directly it is the line joining from the origin to that exact point, exact location of the point. It is the definition of r. What is theta? It is the angle between positive z axis to this r, positive z axis to this r, and the definition of phi remains same. You first take the projected point on xy plane. You first take the projected point on xy plane, then it is your, so you take the projected point. Let us say this is p dash, and you draw. So this angle is phi. So this is the definition of r theta phi. R is the line joining, the distance between the line joining uh, between the origin and the point itself. It is r. Theta is the angle between r and positive z axis, and phi is the same as that of the cylindrical system. Okay, so is there any problem? So these are the three definitions of the three different systems. So exactly these things are written here. For in the note, Cartesian system it is xyz, and the dimension is given. A point is given by xyz. In cylindrical system it is r phi z. So it is, the definition is given in this way. Okay. And similarly, spherical it is something like this. So the diagrams has been represented here. So you can go through the notes. Okay. Now we can quickly doing some mathematics. Let us say if you have spherical, if you have cylindrical. Now can you tell me what is x equals to in terms of r and phi? It's very easy. Quickly, what is x equal to in terms of r and phi?
So
R
r
cos
cos
phi.
phi.
Very good. X equals to r cos phi because it is the adjacent component. X equals to r cos phi, and y equals to
R sin phi.
Sir, R sin phi.
very good, simple, and z equals to
R tan phi.
The tan R tan phi.
z equals to z, y tan phi, z equals to
Sorry,
z.
sir.
Okay, so now if you now using these two, can you tell me what is r equals to using this? X equals to r cos phi and y equals to r sin phi. Can you tell me what is r equals to?
Sir, R is equal to x by cos phi.
Using these two, r equals to
X by cos phi.
no. Using these two,
Sir, root over x square plus y square.
yes,
Sir?
root over under x square plus y square. Root over under x square plus y square. What is phi equals to using these two? This is the I mean the blue shaded equations. Using the blue shaded equations, what is phi equals to? Very easy.
Sir, tan inverse y by x.
Very good.
Sir,
Tan inverse y by x. And obviously z equals to z. So if this is the equation set number 1, and if these three are equation set number 2, then by using these two sets of equations, you can easily transform one point from one coordinate system to another coordinate system. Can you? Can you? So if you know these two sets of equations, so if a point is given 2, 3, 5, if a point is given 2, 3, 5, so now you need to find out its equivalent cylindrical system coordinates. You can do it, right? You can do it. Do you?
Yes, sir. Yes, sir.
So in this case 2 and 3 will be x and y respectively. So r will be 2 square plus 3 square, and 4 plus 9, that is root 13.
Sir, root over 13.
Root 13. Angle will be tan inverse. Angle will be tan inverse. How much? It will be 3 by 2. If you have calculator, you will have the answer, the exact value. And z will be z, it is 5. So in this way you can do it. Okay, in this way you can find out any position. You understood?
Yes, sir.
Anybody having difficulty? I am giving you 1 or 2 minutes time. You please go through this and please highlight if there is any problem or not.
So 2, 3 and 5 এটা এলে কি করে স্যার?
It is at any point. I am showing you an example.
What? Yes, sir.
So now if you look at this spherical system, so can you tell me what is z equal to? X equals to, y equals to, and thereafter z equals to. So you tell me what is, first you tell me z, what is z equals to? Anyone? Very easy.
Sir, cos theta. Sir,
No.
r cos theta.
R cos theta. It's very good. R cos theta. Now can you tell me, one minute, I have to accept a phone call, please. Are you there? Yes. Hello.
Yes, sir.
Okay. Okay. So z equals to r cos theta. That's right. You have said it rightly. And now, can you tell me what is this line equals to? This line. This line. That means what it is r in case of cylindrical system. Now it is not r in case of spherical system. So can you tell me what is this line equals to? So this line is nothing but it will be equal to is r sine theta. So the component, that is the allied component of r, will be z. One component is this, it is r cos theta, and non-alignment component is this, uh, which is r sine theta. So if this is r sine theta, so can you please tell me what is x equals to? If this is r sine theta, so what is x equals to? Anybody? What
R
is x
sin theta
equals
cos theta.
to? R sine theta. Then this is r.
Cos theta.
This is r sine theta. So x will be equal to
R sin theta x cos phi. R sin theta cos phi.
r sine theta cos phi. Good. And y is equal to r sine theta sin phi. R sine theta sin phi. So this is a set. This is a one set. Equation set number, let us say third set of equations. And similarly, if you do the reverse calculation, so can you tell me from these three what is r equal to? What is r equals to? So I'll write down them. You will verify. They are not at all difficult. You just check and do it as a home assignment. X square plus y square plus z square under root. Theta is equal to tan inverse in the numerator it will be x square plus y square under root by z. In the denominator it is z, and the phi will be same. Phi will be same. It will be is equal to tan inverse y by x. Tan inverse y by x. So this is a fourth set of equation. So if you know this fourth set of equation, so you can solve or you can transform any point from any coordinate system to other. Right? So these are the formulas that exactly they are given in this box. If you go through the notes, you will see them. The mathematical guiding rule to convert one point in a three-dimensional space from one coordinate system into other. They are already given, so you can take reference from here. So any doubt?
No, sir.
Okay. So I want to ask you one question. Let us see who can give me the right answer. Let us say -1, 0. A point is given in -1, 0. That is, a point is given in Cartesian system. Now what will be its equivalent? Sorry. Anybody? Hello. Okay. So if a point is given -1, 0, it is represented in a Cartesian system. So what will be its equivalent position in cylindrical system? Can anybody give me the answer? Let us see who can give me the right answer.
Sir, 1 হয় ফার্স্টে 1
1. You please give me the full answer.
Sir, R equal to 2 and I equal to 10 minus and
How? What? You please give me not tan inverse. You please give me the value.
sir,
R is equal to √2.
R equal to √2.
Then
Yes, sir.
phi.
So
Phi.
phi equal to 10 inverse 1.
Tan inverse 1 is how much? You please give me the answer. You should
Sir,
know
R
this.
equals to 2, phi equals to pi by 4, z equals to 0.
Pi is equal to pi by 4, okay, and
4.
z is equal to 0. So this answer, so you are telling, so let me write it fresh. So -1, 0. So one answer came √2 pi by 4 and
0.
0. So any other answer? Anyone who wants to give another answer, or who think it is not right answer?
No, sir.
With everybody of the class, it is okay. This answer, everybody agree with this answer?
Yes, sir.
Yes, sir.
So okay. So
Yes, sir.
who told no? I have heard one person saying no. Who is that? Please share your opinion. Or I have heard wrong.
Sir, he told that he has no doubt. So
Oh, no doubt. Okay.
that's why he said no.
Okay. So
Yes, sir.
I am afraid to say that this answer is wrong. Totally
No,
wrong.
sir, he said that he has no doubt.
Okay. So I am afraid to say that this answer is totally wrong. So you please give a second try. You can give a second try. This answer is totally wrong. Who can give me a second try? Any alternative thoughts? Are you any idea that why this is wrong? What could be the reason?
No, sir, no idea.
No idea.
No idea, sir. Would-
Hmm. You forget about z axis. Okay, you consider this is a simple graph paper. What graphs you used to make in your 9th standard or 10th standard in Madhyamik? So you consider only that. It is x-axis. This is y-axis. Anyone can tell me means where should it locate? -1, -1. Means what is the position of this point? -1, -1, -1, -1.
স্যার প্রথমে এক্স ড্যাশ দিয়ে যাবে তারপর ওয়াই ড্যাশের দিকে একটু নেমে আসবে
So something around here. So something around here.
ইয়েস
Right?
Okay, sir.
Agreed? So
Yes.
it is situated in third quadrant. It is situated on third quadrant. This is first. This is second. This is third. This is fourth. So -1, -1 will be situated on the third quadrant. What is the range of angle in the third quadrant?
Sir, 10. Sir, 10.
No, not 10. I am asking what is the range. That means this angle.
Sir, pi to 3 pi by 2.
181 থেকে
Yes. 180 to 270.
ইয়েস
180 to 270. So the position of this, it cannot be the equivalent position. It cannot be pi by 4 because this point pi by 4 is you are telling about the any position around on first quadrant. Okay, because the range of the angle between 0 to 90. So pi by 4 stays on the first quadrant. It cannot stay on the third quadrant. Okay. So now you please tell me the answer. What should be this angle? Now you should
7
answer.
pi by 4.
first part, sir.
Sorry,
7 pi by 4.
7 pi by 4 means what?
So minus pi by 4.
No. I told you na. You please tell me the numeric value. You forget about pi by 4. You tell me the numeric value in degree. You tell me.
225.
225 is the right answer. So in gist, if a point is 1, 1, then its equivalent position will be √245. √245. If a position is -1, 1, if the -1, 1 is the position, then its equivalent point is √2, 135. This one I have already discussed. And fourth one is if the point is minus 1 and 1, 1 and minus 1, and its equivalent position is root 2 315 degree or root 2 minus 45 degree. So this is very important to understand. This is very important to understand. Okay. So whether it is 1 1 minus 1 1 1 minus 1 minus 1 minus 1, the magnitude remains same, r remains same, it is root 2. However, the angles remains changing depending on the position of the point. Okay, so any doubt?
স্যার ফোর্থ কোয়াড্রেন্টে রুট টু মাইনাস
315টা কি করে লেখা করে বলুন স্যার? স্যার 315টা কি করে লেখা করে বলুন?
315 মানে why? Because
270 plus 45.
225 plus 90 or 360 minus 45, because this point is located on fourth quadrant. So it is 270 and in between 360, so it is just the midway. That is why it is 315 degree. Any other doubt? Another guy was asking something.
স্যার মাইনাস 45 ডিগ্রি যেটা লিখেছেন ফোর্থ কোয়াড্রেন্টে ওটা তো স্যার মাইনাস 45 ডিগ্রি কি করে হবে?
Minus 45 degree, in some sense it is right, because in electrical engineering we have the conventional rotation is anti-clockwise direction. That means in this way it is the positive rotation. Now if you just consider the reverse direction, that is the clockwise direction, then you can use this kind of notation, minus 45 degree. Okay.
Okay, sir.
When the concept of lagging, leading will come, say let us this is R phase, then Y should be lagging by an angle of 120 degree. 120 degree means what? It is negative angle. So if R is reference phasor, it is represented by this notation R angle 0, then Y must be represented by Y angle minus 120 degree, because Y is the lagging behind R by an angle 120. Similarly, B, the third phase of our electrical engineering, B is same, is lagging another by 240 degrees. So B can be written as minus 240 degree. So it's the all conceptions. Okay, this is another 120 degree lagging. So should we go to the next topic?
Yes, sir.
Any question? Okay. So in Cartesian system, we have Cartesian system. Sorry. Cartesian system, we have three parameters as x, y, z. Now I am floating a question. Any answer will be welcome. What will happen if x remains constant? what will happen if y remains constant? And what will happen if z remains constant? When you say some answer, you tell me, you try to think in that this way, that x equals to constant means when you put x equals to constant, then what geometry will evolve? What geometry will it evolved? Will be evolved. So try to think. The sum part of this question has already been answered in this class. What will happen when z equals to constant? I have already discussed. So you try to think, and you please tell me, if you keep x equals to constant and y and z vary, then what geometry it will evolve? If you keep y equals to constant, x and z vary, then what geometry it will be evolved? And similarly, if z equals to constant, x and y are varies, then what geometry it will be evolved?
Sir, if z is equal to constant, then it will be spherical.
Please think, then answer. Don't answer in this way, randomly. Think, then answer.
Sir,
Understand, then answer.
sir,
Yes,
x is
yes.
equal if x is equal to constant, then the point is in yz plane.
YZ plane, then okay, YZ plane. That most importantly, so okay, your answer is YZ plane. ठीक है, it's right answer. No issue. So it is. So it is evolving YZ plane. You are telling. Good. So it is YZ plane. And this is, if y is equal to constant, then it must be XZ plane. And if it is x equals to constant, then z equals to constant, then it must be XY plane. I have already told you it is either roof or floor. As a practical example. So in all cases, they will generate a linear plane. Most importantly, in all cases, they will generate a linear plane. Okay, all will be linear plane. You can visualize. You consider these 6 walls or 6 surfaces of your rooms. 6 surfaces of your room: floor, roof, and 4 roof, floor, and 4 walls. They are all linear planes. They are all linear planes. Okay, not curved planes. They are all linear planes. And now you quickly tell me, in case of cylindrical system, in case of cylindrical system, the variables were x, r, phi, z. r phi z. Now when r is constant, what will happen? If phi is constant, what will happen? And if z is constant, what will happen? Is anybody, if you can answer this, you will be very much welcome. So this is the diagram for you for cylindrical system. If r is constant and if you keep varying phi and keep varying z, what geometry it will evolve? What geometry it will evolve? If phi is varying like this, okay, and if z is varying like this, so what geometry it will be evolving? And r is constant here. R is constant. So what geometry it is evolved? Hello, are you there? So it is evolving cylinder. It is evolving cylinder. It is nothing but it is evolving cylinder. And if phi is constant, then what geometry it will evolve? It will again a linear plane. And similarly z constant, it will evaluate linear plane. So we have seen from three linear planes we have generated. If you go to the cylindrical system, we have generated two linear planes and one curved plane. Cylinder is obviously a curved plane. It is no longer a linear plane. And finally, if we go to our third system, spherical, then its parameters are r theta phi, r theta phi. So then if r is equal to constant, what will happen? R is equal to constant, what will happen? Theta is equal to constant, what will happen? And z equals not z, phi is equal to constant, what will happen? So this is the picture for you for the cylindrical system, a spherical system. So you tell me, if you take r is equal to constant, and if you vary this theta and if you vary this phi, so what will happen? So it is,
So it will be a circle or curve.
not circle, it will generate a sphere.
Sir, spherical.
It will generate a sphere. It is little difficult to visualize. You can try this at home. If theta is constant remains, okay, let's go back to the diagram. If theta is constant, and if you try r varying and theta varying like this, if you vary this theta like this, in this way, and if you vary this r in this way, then it will generate a What?
Cone, sir.
Not cone. It will be generating a inverted cone. It will be generating a inverted cone. It will generate a inverted cone. And finally, if phi is constant, then it will generate a linear plane like previously. A linear plane. So we have seen two planes are curved, plane, and one planes are linear plane. So we have started with Cartesian, so where all planes are linear. Now then we move to cylindrical, where we find one is curved. Cylindrical is obviously curved plane, and these two are linear planes. So two linear planes and one curved planes. And finally, when we move to the spherical, then we find two curved planes or non-linear planes and one linear plane. So this is not end of the coordinate system. When we or at the time of the when we send the spaceship to the space, then at that on those occasions, those everything is non-linear there, because the distance is quite large. So with respect to those large distances, every dimension becomes non-linear. So although in spherical system you will observe that one linear plane is there, but if you go and search for other coordinate system, this is not the end. Obviously, this is end for the sake of this course only, but if you go and search for other coordinate system, then it is not the end. There are lots of other coordinate system as well, where you will find there are all the parameters are non-linear, all the planes were non-linear, because to tackle such high distance, high altitude, high distance, large distance, everything becomes non-linear. Okay, so this is all for today. So today somewhat introduction of coordinate systems has been given, and how do you convert one point to another, it's given, the idea has been given. So this is all from my side. If you have any question, you can ask me. I am giving you one. Ask me. If you have any question, you can please ask me.